Preparing for a platform engineering at Goldman Sachs interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain the role of a platform engineer in a regulated financial firm like Goldman Sachs? Platform engineering builds internal products that make delivery safer, faster, and more repeatable. In a bank, I would focus on paved roads, standardized CI/CD, Kubernetes templates, secrets, observability, policy checks, and self-service provisioning. DevOps emphasizes team practices, while SRE emphasizes reliability targets. Platform engineering combines both, but treats developers as customers. The key is reducing cognitive load without hiding critical controls required for financial systems. While answering, distinguish platform engineering from DevOps and SRE, then connect it to developer productivity, reliability, compliance, internal tooling, standardization, self-service, and regulated financial environments. Question 2. How would you roll out a new version of a critical service on Kubernetes with minimal production risk? For a production rollout, I want small blast radius first, readiness probes, canary or blue-green deployment, automated rollback, and metrics tied to business impact. In Kubernetes, I would use deployment strategies through Helm or Argo CD, validate health with Prometheus alerts, and keep configuration externalized. If latency or error rate crosses threshold, rollback should be automatic. In financial platforms, safe deployment matters as much as deployment speed. Make sure to cover deployment strategies, readiness and liveness probes, canary releases, rollback automation, health metrics, Helm or GitOps workflows, and reducing blast radius in production. Question 3. How do you manage infrastructure as code safely across development, UAT, and production environments? Infrastructure as code gives platform teams a versioned, reviewable way to manage environments. I typically structure Terraform into reusable modules, separate state per environment, and enforce policy with tools like Sentinel, OPA, or pipeline checks. Idempotency is critical. Repeated runs should converge safely. In a Goldman Sachs context, I would also require peer review, audit trails, least privilege credentials, and clear rollback plans for infrastructure changes. In your answer, talk about Terraform modules, environment separation, remote state idempotency, peer reviews, policy enforcement, auditability, secrets handling, and rollback planning. Question 4. What would a secure and compliant CI/CD pipeline look like for a platform used by multiple engineering teams?
A strong CI/CD pipeline is a control system, not just automation. I would include static analysis, unit and integration tests, container scanning, artifact signing, deployment approvals for sensitive environments, and automated promotion across dev, UAT, and production. Build artifacts should be immutable and traceable to commits. For regulated finance, evidence matters. Every release should show who changed what passed, and when it was deployed. Be sure to mention source control triggers, automated testing, scanning, artifact management, approval gates, immutable builds, deployment promotion, traceability, and compliance evidence. Question 5. A Linux-based production service is slow. How would you troubleshoot it from the platform side? When a service is slow, I start with symptoms, not guesses. I check CPU, memory, disk I/O, network, and process behavior using top, VMstat, IOStat, SS, LSOF, journal CTL, and application logs. Then I correlate with deployment events and metrics. If CPU is high, I inspect thread dumps or profiles. If I/O weights spike, I check storage. The goal is fast isolation before changing anything blindly. While answering, focus on systematic diagnosis using CPU, memory, disk, network, process inspection, logs, recent changes, profiling, and avoiding random fixes before identifying the bottleneck. Question 6. How do metrics, logs, and traces work together in an observability platform? Metrics tell me what is happening. Logs explain specific events, and traces show request flow across services. For a platform, I would standardize dashboards,
golden signals, correlation IDs, structured logs, and alert ownership. Alerts should map to user impact, not noisy thresholds. In trading or risk systems, latency, failed transactions, queue depth, and dependency health are especially important because small degradations can become business incidents. Make sure to cover the purpose of each signal, correlation IDs, structured logging, distributed tracing, golden signals, alert quality, dashboards, and business impact-driven monitoring. Question 7. What are SLOs and error budgets, and how would you use them to manage reliability? An SLO defines the reliability target users can expect, like 99.9% successful requests under 200 milliseconds. I would derive it from business needs, measure it with SLIs, and track error budgets. If the budget burns too fast, feature velocity should slow, while reliability work takes priority. This creates a practical conversation between engineering, product, and operations instead of arguing over vague uptime expectations during incidents. In your answer, define SLIs, SLOs, SLAs, error budgets, burn rate, reliability versus feature velocity, and how these concepts guide operational decisions. Question 8. How would you manage secrets, API keys, and certificates for applications running on a shared platform? Secrets should never live in source control, container images, or plain environment dumps. I would use a secrets manager such as Vault, AWS Secrets Manager, or Kubernetes External Secrets, with short-lived credentials and rotation. Access should be identity-based and audited. For certificates, I automate issuance and renewal, monitor expiry, and avoid shared keys. In finance, secret leakage is both a security and regulatory risk event. Be sure to mention secrets managers, short-lived credentials, rotation, audit trails, least privilege, certificate renewal, Kubernetes integration, and avoiding secrets in code or images. Question 9. How would you design a self-service developer platform for provisioning services and infrastructure? A self-service platform should expose safe primitives, not raw infrastructure complexity. I would design APIs for common workflows, create service, request database, configure pipeline, view logs, and deploy. Behind the scenes, templates enforce naming, security, network policy, and observability. Good developer experience needs documentation, sensible defaults, and fast feedback. The platform succeeds when teams move faster, while compliance becomes automatic, rather than manually enforced later. While answering, focus on developer experience, platform APIs, service templates, guardrails, policy as code, documentation, golden paths, ownership, and reducing manual operational tickets. Question 10. Where would you use a message broker like Kafka in a financial platform, and what failure modes would you consider? Messaging decouples producers from consumers and absorbs bursts, which is valuable in market data, risk, and workflow systems. With Kafka, I would discuss topics, partitions, consumer groups, ordering, offsets, and retention. The tricky parts are idempotency, replay behavior, schema compatibility, and back pressure. I design consumers to handle duplicates because exactly once semantics are limited and usually require carefully defined transactional boundaries across services and databases in production systems. Make sure to cover asynchronous communication, partitions, ordering, consumer groups, offsets, retries, idempotency, schema evolution, back pressure, replay, and duplicate message handling. Question 11. How would you investigate database performance issues affecting a platform service? In a platform role, I look at database performance from both application and infrastructure angles. I check query plans, indexes, connection pools, transaction scope, lock contention, and replica lag. Caching helps, but stale data can be dangerous for financial workflows. I also monitor saturation signals and set safe limits. The best fix might be query redesign, not simply adding a bigger database instance under pressure. In your answer, talk about query plans, indexing, locks, connection pools, transactions, caching, replica lag, saturation metrics, and distinguishing application issues from database bottlenecks. Question 12. What security practices would you enforce for container images and runtime workloads? A production container should be minimal,
reproducible, and scanned. I prefer slim base images, pinned versions, non-root users, read-only file systems where possible, and no secrets baked into layers. The pipeline should generate SBOMs, scan vulnerabilities, and sign images before promotion. At runtime, Kubernetes policies can restrict privileges. This reduces attack surface while keeping deployments predictable and auditable for regulated production environments across all clusters consistently. Be sure to mention minimal base images, vulnerability scanning, SBOMs, image signing, non-root users, runtime policies, read-only file systems, privilege restrictions, and supply chain security. Question 13. Walk me through how you would handle a major production incident on a shared platform. During an incident, I separate mitigation from root cause analysis. First, I confirm impact, declare severity, assign roles, communicate status, and stabilize the system through rollback, failover, scaling, or feature flags. After recovery, I run a blameless postmortem with timeline, contributing factors, and action items. In finance, communication discipline is critical because incidents affect users, risk teams, and regulatory obligations, as well as revenue protection goals. While answering, cover severity assessment, incident roles, communication, mitigation, rollback or failover, customer impact, postmortems, action items, and blameless learning culture. Question 14. A service cannot reach another internal service. How would you troubleshoot the networking path? Networking problems often look like application failures, so I verify the path layer by layer. I check DNS resolution, routing, firewall rules, security groups, TLS handshake, load balancer health, and service discovery. Tools like dig, curl, TCP dump, traceroute, and OpenSSL help isolate the failing hop. In Kubernetes, I also inspect services, ingress, network policies, and pod endpoints before blaming code or restarting services randomly in production. Make sure to discuss DNS, routing, firewalls, load balancers, TLS, service discovery, Kubernetes services and ingress, network policies, packet captures, and layer-by-layer debugging. Question 15. Tell me about a time you improved a platform capability used by multiple teams. For this question, I would use a concrete star story. I describe the legacy pain, my role, the migration plan, stakeholder alignment, rollout strategy, and measurable result. For example, moving teams from manual deployments to a standardized pipeline can reduce failures and audit gaps. I would emphasize collaboration with developers, security, and operations. Goldman Sachs will value execution, risk awareness, and clear ownership under constraints. In your answer, use star structure and highlight ownership, stakeholder alignment, migration strategy, measurable impact, risk management, communication, and how you balance speed with stability. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.